So next, I'm going to talk about the testing requirement for your transmitter. So from the high level, there are three broad groups of transmitter test group that you need to qualify or test your products to. And they are the PHY, the TSG, and also the OOB. So the PHY stands for the physical layer, which check for the data rate, the SSC profile, as well as the frequency long-term stability of your high-speed signal. And the TSG, or the transmitter signal group, will check for the the amplitude level, the rise-fall time, and the jitter performance on your product. The third group is the OOB, which stands for the out-of-band signaling. And before you can go to high-speed transmission mode, you need to have a handshake between the host and the drive before going into the high-speed mode. And that's why, hence the OOB handshake. The OOB testing will require a stimulus and transmitting all the stress signal into your drive or your host, and check how your host or your drive or your product will respond to those stimulus. And some of the tests will send out of spec OOB sequence where the product should not respond, and we need to check if that's the correct behavior of the product. And we are sending an in-spec OOB sequence, then we would expect the product to respond to that stimulus. For high-speed transmission testing, there are four main patterns that you need in order to qualify your designs or your products. They are the HFTP signal, which stands for high frequency test pattern, the MFTP, mid frequency test pattern, LFTP, low frequency test pattern, and also LBP, the lone bit pattern. So you need these four different patterns in order to stress the different characteristics of your product. So how do you generate the test pattern that you require for the transmitter tests? So you need to put the device into a test mode, and the test mode in the SATA term is called the BIST mode. And there are two BIST mode that is allowed, which is called BIST TSA, which stand for transmit, no scrambling, and no aligns. So you can use your internal hook or external instrument to put the device or the product into the BIST TSA mode for it to generate the test pattern that you need for the test. And the next BIST mode is the BIST L, where the L stands for loopback. So what you do is you have an external instrument that can generate the test sequence or the test pattern sequence into the product, and the product will loop back that same test sequence into the scope for the transmitter measurement. So this is what I meant by the BIST L, where it's in loopback mode, and it'll be able to loop whatever signal going into the product.